In this topic, we are going to cover project number 5, Encrypted Bind Shell. In this project, we are going to create an encrypted bind shell. A bind shell, in this case, is just a socket which we can connect to in order to execute commands on a system via the network. To start, let's first focus on creating a bind shell. Then, once we know that it works, we can improve it by adding some encryption. So let's start by importing some useful modules for this task. Let's import socket, subprocess, threading, and argparse. And we can save this, project5.py. And we can also configure some variables for a default port and a maximum buffer size for our socket. And an important part for our bind shell is going to be the ability to execute a command on the system. So let's first start by creating an execute command. And this function takes as a parameter the command to execute. We can use a try except here. And our exception can just be command failed. And lastly, we want to return the output. So we can test this. Let's print this out. And here we can see the output of executing the whoami command. And if the command doesn't exist, or if there's some error which isn't caught, then we receive command failed. So this is working as expected. And we will be decoding and stripping a lot of data as part of this process. So let's set up a function to do this for us in a central location. And next, let's start working on our shell thread. And this is the thread which will handle new user connections. And we want to use threading here because we want to be able to have more than one user connect to the bind shell and use it. So let's set up our shell thread, which takes a socket as a parameter. And we can send over the socket, enter command. And next, we want to receive data up to the maximum buffer size. And if we've received data, we can decode and strip it. And if nothing's been sent, or our buffer is telling us to exit, then we want to close the socket and exit. Otherwise, we want to print out executing command. And then we want to send through the socket what happens when we actually execute our command. And actually, in our shell thread, we want to be executing this within an infinite loop. So while true, and when we first connect, we want to tell the user that they've connected. And then in our infinite loop, we can listen for commands from the user. And if some error occurs, then we can close the socket. And so this will be our shell thread, which is just an infinite loop waiting for commands from the user. When a command is received, we either exit our infinite loop or we execute the command and we send the result back to the user over the socket. And now that we have this function set up to actually execute commands in a thread, we can now start working on adding 2 more thread-capable functions. In order for a bind shell to function without relying on another tool, we need to be able to have dual functionality. Our script needs to be able to listen and accept connections, and also be able to initiate connections. So, we basically need to be able to run our script in both server and client modes, depending on how we start the script. When we connect as a client, we also need to have the ability to both send and receive data at the same time. Otherwise, we will get stuck waiting for input and output. This is because send and receive socket functions don't return immediately. They instead will wait on system calls before they return a value, which basically means we, as the caller, are blocked waiting for them to complete or to time out. So let's start by creating our send data function, which takes a socket as a parameter. We again set up our infinite loop. We accept data from the user on the command line. Then we send that data over the socket. And we do this until we have some error. So now we can send data, but we also need to receive it. So let's set up our receive thread, which again takes a socket as a parameter. We keep the thread alive with our infinite loop. We receive and decode any data received by the socket. And if we have data, we can print it out. So now we have thread-capable functions to handle sending data, receiving data, and executing shell commands. So now let's implement our server and client functions. So for our server, we set up our socket. And for the server, we want to bind on our default port. And then we want to listen for connections. And we can print out starting bind shell. And now we want to wait for our connections to come in. And when they do come in, we accept them. And we can print out new user connected. And then when we receive a connection, we want to start a new thread. We want to pass in as an argument the client socket. And we want to start this thread. So now, when the server receives a connection, it will give the user the ability to execute commands as if they had just opened a command.exe terminal on their machine. But how can a user connect? Well, we could use Telnet or PuTTY to connect to our server, but since this is a Python course, let's also add the client functionality now as well. we can set up a client, and the client takes an IP address to connect to. And then tries to connect to the default port on that host. And we can print out connecting to bind shell. And now that we have connected, we can start up both our send thread and our receive thread, so we aren't stuck or blocked while waiting to send or receive data. And we aren't doing any error checking here. However, for this simple example, that isn't really necessary. So we need to set up our send thread, and we pass in the socket, and we start this. We also start our receive thread, and we pass in the socket. And now that we have the core functionality in place, we need a way to actually execute the script differently, depending on whether we are trying to listen as a bind shell or connect to a bind shell. And we can do this using argparse. So we can create a new parser. And to start the server, we can specify a listen mode to listen for connections as a server. And to connect to a server, we specify to connect and pass in the IP address of the server we want to connect to. And then we can parse these args. And now that we've parsed them, we just need to specify what we want to do based on the command line arguments passed by the user. So if we're trying to listen, we can start the server. And if the user specified to connect to an existing server, we can do that instead. And now we can try to execute this. And we can see if we parse in -h here, our argparse descriptions. And the first thing that we want to do is we want to set up a bind shell that we can then connect to. So let's listen for connection by passing in -l. And here we can see starting bind shell. So now if we start another terminal and we go into our directory, we should be able to now connect to our bind shell. And we want to connect on the local host. So we have a typo. Let's fix this up. And here we can see that we've connected to our bind shell. We can see on the server that we've identified a new user has connected. And now we can enter commands. Who am I? And these commands are being executed via our bind shell. There is a problem though with our current setup if we think about this from a security point of view. In this demo, I am running and connecting to the bind shell on the same local system. But because of the way that the server starts, and depending on local firewall configurations, we could also connect to this bind shell from another remote system. If we did do this and we executed sensitive commands via this shell, we would have a problem. because all of our commands are sent and received via an unencrypted connection. And we can see this in Wireshark as well. And so here in Wireshark, when using the correct adapter, we can see our commands in plain text as they're being passed over the wire. So we entered, who am I? We sent that to the server, and then we received as a response the current user. So what can we do about this? Well, we can add some encryption. And just like we discussed during the PyCryptodome lesson, we aren't going to use proper encryption. We are just going to use some encryption to avoid sending potentially sensitive information over the network unencrypted. And to make our lives easier for a future lesson using Burp, let's make a copy of this unencrypted version. So I'm going to create a new file here and save this project5 encrypted.py. We can close the unencrypted version here. We can kill this bind shell and the client. And now we can start adding encryption to our bind shell. And to add encryption, we will first need to import some functions from PyCryptodome. So from crypto.cipher, import AES. Import get random bytes. Let's also import some padding functions. And next, we want to set up a class to handle our encryption. And to make this easier to implement, let's use symmetric encryption with a shared key, rather than trying to include the added complexity of asymmetric encryption for this lesson. So let's create the class AES cipher, define our init function, default key of none, and now we can set up our key, and that can be key if key was passed in. Otherwise, let's generate a random key. Next, we can specify a weak AES cipher in ECB mode with that key. And now we need a function to actually encrypt our data. And we want to encrypt plain text. And we can hex encode this. And we also want to have a function to decrypt encrypted data. And we're using these functions in the same way as we described in the PyCryptodome lesson. And let's also override the string function. So when we print the object, we can print out the object's encryption key, because otherwise we won't necessarily know what it is. And now that we have our AES cipher class defined, let's also create a helper function to actually send our encrypted data. Encrypted send. And we need a socket and a message. And we can send encrypted message encoded. And now that we have these encryption functions in place, we need to change the way we send data over the socket. So basically, we need to change all of our plain s.send functions to instead make use of this encrypted send. So let's go through and change these by searching for s.send. We'll change this to encrypted send, encrypted send. However, we also need to change how we're using this. So we need to pass in the socket as well as the message. And now that we've changed how we're sending data, so now we're sending data in an encrypted way, we also need to change what we do when we receive data, because now we also need to decrypt that encrypted data once we receive it. So let's find all the places we receive data. So now the buffer needs to be cipher.decrypt, decode and strip data. And again, we've received our data, but it's currently encrypted. So let's decrypt it. And we can also get rid of this new line now. So now we can send and receive encrypted data transparently to the user. However, we also need to include a way to specify an encryption key. So for example, we might want to use some hard-coded key or specify a known key to connect to an existing bind shell server. Because now, without the key, it's difficult for us to send and receive messages to the bind shell. And in order to do that, we need to be able to pass in the encryption key as part of execution. So we can just add another argument to argparse. So let's do that. And this should be a string. And now we also need to change what we do after we parse our arguments. Because if we are trying to connect to a bind shell, we need to include the encryption key. Otherwise, the server won't know how to communicate properly. And now, if we specified a key, we create a new cipher and pass in that key as an argument. Otherwise, we start a new cipher with a random key. And we can also print out the current encryption key that we're using. And otherwise, it's business as usual when using the bind shell. And now, let's try this out using encryption. So we can specify that we first want to listen. And here we can see the encryption key that our bind shell is currently using. And now that our bind shell is listening, let's connect. And when connecting, we need to specify the key. So let's do that. And here we can see the familiar user interface. However, we have some problem with our code. So let's figure out what we've missed here. And so here, we don't want to be decoding and stripping the data, just the buffer, because otherwise it's still encrypted, which we can see here. So let's try this again. And we have a new key. And here we can see that we've again connected to the shell. And now when we enter a command, we can see the response. And we can also take a look in Wireshark. We can take a look at these packets. And we can see that instead of plain text here, we now have encrypted data, encoded and encrypted data, which is harder to identify over the wire. However, ECB is not necessarily a good cipher for this purpose. However, the argument could be made that it's still better than using plain text. And we can also see what happens when we use the wrong key here. So this is the encryption key that's expected. So if we change the 5 at the end to a 6, for example, we can see that we've connected. However, we're not able to send any commands. And that's because the server doesn't understand how to decrypt and interpret the encrypted data that we're sending if we use a different key. In this lesson, we have shown how to use sockets, threads, and cryptography to create a multi-user bind shell which has support for both server and client functionality depending on how a user starts the script. The encryption we have used here is not really suitable for this purpose and could be broken by an attacker. However, for this Python 201 for Hackers course, this example is sufficient to demonstrate how you can use encryption in your projects. But that's it for now, and in the next lesson, we are going to cover an introduction to extending burp.